right, as we get started, turn your textbooks, if you would, page 60. Page 60, where we did numbers 1 through 12, practicing rewriting functions in terms of the same function of a positive acute angle, getting that reference angle, something that could fit in a triangle, where maybe we didn't start with something that fits in a triangle. So what's the answers? The answer is a function with some sort of positive or negative and the angle with it. Okay, so make sure you do exactly what we do in class. That's why everything's done in a spiral notebook, very neat, or whatever this nonsense is. So that way you can follow through everything we did in class. You can see exactly what we were doing. So on number 1, we were supposed to reduce the tangent of 230 degrees to the same function of a positive acute angle. And the first thing we have to make sure of is that the angle ain't ugly. We got to make sure the angle class is between 0 and 360. And of course it is. Once we've identified that it is, we should easily be able to identify which quadrant it falls into. And of course 230 degrees, Quentin, falls into quadrant 3. In quadrant 3, the question is how far from 180 is that angle? Because that'll tell me my reference angle. And of course here the reference angle is 50 degrees. The final question is ASTC. Is this going to be positive or negative? And it's going to be positive, because in quadrant 2, this is Quentin's problem. In quadrant 3, tangent's positive. So how do I rewrite this function as the same function of the positive acute angle?
Positive tangent 50.
The positive tangent of 50 degrees. So we're going to have the sine from ASTC. We're going to keep the same function and the reference angle. On number 2, we have the cosecant of negative 13 pi over 9. So thought number 1, it's in radians. But thought number 2, Ethan, that angle isn't between 0 and 2 pi. It's negative. What do I need to do?
Add
2 pi, right? But how is my 2 pi going to look? I'm not going to just write 2 pi. I'm going to write it as a fraction. Well, that'd be half of it. I want 2 pi, right? But I want a denominator class of 9, because you can't add fractions without a common denominator. What would 2 pi?
18 pi.
Right, 18 pi over 9, right? So I'm going to add 18 pi over 9 to the negative 13 pi over 9 to get the cosecant of 5 pi over 9. And then the question comes, what quadrant is this in? And it's just barely into quadrant
4.
Well, let's again, I like to usually mentally do this, but I'll draw it for the sake of visualizing here. Here's 2 pi, or 18 pi over 9. Here's plain old pi, or 9 pi over 9. Where is 5 pi over 9 in relation to these angles?
It's in quadrant 2.
It's just barely into the second quadrant. In fact, 4.5 pi over 9 would technically be pi over 2, right? It's just a little bit past that. So it's just barely in quadrant 2. And that's the question. What quadrant are we in? Well, quadrant 2. The next question comes, how far from
180.
180, the x-axis. Or in this case, instead of saying 180, we'll say 9 pi over 9. How far from 9 pi over 9 is 5 pi over 9?
4 pi over 9.
So the reference angle is 4 pi over 9. The last question we'll ask is ASTC. In the second quadrant, is cosecant positive or negative?
Positive.
Positive. So what's my answer?
It is positive cosecant 4 pi over 9.
There we go. Positive cosecant 4 pi over 9. Chris, on number 3, they start us off with the sine of negative pi over 8. But once again, we've got a negative angle. Well, what do I do with the negative angles?
Make it positive.
Make it positive by adding?
By adding 2 pi.
Right, normally 360, in this case 2 pi, but how is my 2 pi going to look?
Negative 6, or positive 16 pi over 8.
Right, and then what is the 16 pi over 8? We're going to add 16 pi over 8 to a negative 1 pi over 8, and that's going to give me the sine of 15 pi over 8. Now it's between 0 and 2 pi. Again, we're going to picture, here's pi, here's 2 pi. Where is 15 pi over 8 in relation to pi or 2 pi?
Right, as close as you can get it to 16 pi over 8.
Right there. I mean, it's almost a full 2 pi, right? So clearly in quadrant 4. And in the fourth quadrant, I'm not comparing how far to 180. I'm going with the other side of the x-axis, how far from 360, or in other words, how far from 16 pi over 8. Well, clearly here the reference angle is
Pi over 8.
Pi over 8. So last question, ASTC, quadrant 4, sine is
Negative.
negative. So how do I write my answer?
Negative 7 equals pi over 8.
Not equals, negative sine of
Pi over 8.
pi over 8. There we go. And that should be our answer there. Number 4, we've got the sine of negative 30 degrees. They like these negative angles, don't they? Quentin, what do we need to do?
Yeah, 360.
This time it's 360. And when I add the 360, that's going to change this into
Sine of 330 degrees.
good, sine of 330 degrees. Now I can identify what quadrant.
4.
I can identify the reference angle, remembering again in the 4th quadrant it's how far from 360,
So 30 degrees.
and ASTC.
Negative.
So my answer,
Negative sine of 30 degrees.
the negative sine of 30 degrees. Looking at number 5, Ethan, we have the secant of 165. Finally, something that isn't negative, and it's already between 0 and 360. What quadrant?
2.
2. The reference angle in quadrant 2 is measured from,
180.
how far from 180 is 165?
15.
15 degrees. ASTC,
Secant equal. It is negative.
negative, so my answer,
Is secant negative secant 15 degrees.
negative secant of 15 degrees. Number 6, Chris, we've got the cosine of 655 degrees, and obviously that angle,
Minus 360.
right, way too big. We're going to subtract 360. When we do, what do we get?
295.
I'm sorry?
295.
Good, so we're going to get the cosine of 295 degrees. Okay, now we can identify the quadrant.
Third quadrant.
Well,
Fourth quadrant.
yeah, because remember the 270 is kind of the dividing line between them, and 295 is beyond the 270. So we're actually out here, 4th quadrant. And in 4th quadrant, I'm comparing my angle to 360. How far from 360 is 295?
75.
65 degrees. Careful on your borrowing there. And so, last question, ASTC, quadrant 4, cosine is,
Positive.
so my answer,
Is positive cosine of 65.
there we go, positive cosine of 65 degrees. Now that we've gone through the first 6 questions, I've kind of been moving at a quick clip. Now that we've seen 6, are there questions on this? Or do we feel like, okay, even if I wasn't getting it in the homework, I've got it now? Feel like we've got, how many say, I got it in the homework, so I'm good already, okay? And it makes sense now? All right, let's keep going then. Number 7, we had the cotangent of 277 degrees. Class, already between 0 and 360, so what quadrant?
Number 4.
Just barely into that 4th quadrant, isn't it? Where the reference angle, measuring from the 360, is going to be 83 degrees. ASTC, quadrant 4 class, cotangent is,
Negative.
so my answer,
Negative cotangent of 83 degrees.
negative cotangent of 83 degrees. Number 8, we had the tangent of 9 pi over 7. And hey, it's also not negative, so I don't have to add 2 pi. It's not too big. I don't have to subtract 2 pi. I can just go. But I want you to picture, pi, class, would be 7 pi over 7. 2 pi would be 14 pi over 7. I have 9 pi over 7.
So second quadrant.
Quadrant 3.
It's beyond the, that would be important. All right, it's beyond the 180, right? This is 7 pi over 7 here. It's beyond, that's at 9/7, right? So it is quadrant 3. How far beyond 7/7 is 9/7? 2/7, right? So the reference angle is 2/7 pi, or 2 pi over 7. And in quadrant 3, ASTC class, tangent is positive. So my answer, good. And I want you to start mentally. Like I kept drawing in the last lesson the quick x-axis. If you need that, go ahead. But we're seniors. I feel like we can mentally do the 7/7, 14/7. Okay, 9/7 is beyond that. Does that make sense? I think we can. If not, by all means, it's not a problem to draw. It just slows you down a little bit, I think. For the next, we have the cosecant of, here we go again, negative 11 pi over 12. What do I have to do, class?
Change to positive.
Or
Add 2 pi. How is my 2 pi supposed to look?
13 pi over 12.
Well, adding 2 pi,
24 pi.
add 24 pi over 12, so that my problem now becomes
13 pi over 12.
Cosecant of 13 pi over 12. Now, picture it. Pi would be
12 pi over
12 pi over 12,
24 pi.
24 pi over 12, so where's 13 pi over 12? Quadrant 3, just barely into that third quadrant. How far beyond pi? 1 pi over 12, right? And ASTC,
Positive. Or negative.
negative, so negative cosecant pi over 12. Okay? Questions on these next few that we've done? Questions on these next couple? All right, let's take a look at number 10. We have the sine of 725 degrees. Thoughts, class? Minus 360 to get? 365. Okay, now thoughts, class? Minus 360 again to get? 5 degrees. Wait, that's already acute. That's quadrant 1. I'm done. Once you have a quadrant 1 angle, you're finished. And I've got the quadrant 1 angle, so I don't have to do anything else. How many got that on number 10? All right, questions on that?
I actually got that one.
What is the other one?
All right, number 11. We have the cosine of 3 pi over 4. Not negative, not too big. Over here at pi class is 4 pi over 5, over 4. 8 pi over 4. Where's 3 pi over 4?
Second quadrant.
Second quadrant. It's not quite 2 4/4. It's up here somewhere, 3/4. So quadrant 2, how far from 4/4 is 3/4?
1/4.
So there's my reference angle, pi over 4. ASTC?
Negative.
Negative. So my answer,
Negative cosine of pi over 4.
negative cosine of pi over 4. And the last one, number 12. They give us the secant of negative 19 pi over 6. What are we going to have to do? Well, add 2 pi, right? But how's the 2 pi going to look?
12 pi over
12 pi over 6. So when I add 12 pi over 6, what do I get?
7 pi. Negative 7 pi.
Negative 7 pi over 6. What do I have to do again?
Or plus 2 pi.
Plus another 12 pi over 6, plus another 2 pi to get?
5 pi over 6.
All right, so finally this becomes the secant of 5 pi over 6. All right, at pi we have 6/6. 12/6. Where is 5/6?
Second quadrant.
Just before we get to the full pi, so quadrant 2, reference angle,
1 pi.
pi over 6. Right? It's pi over 6 away from the 6/6 of a pi. And ASTC?
Negative.
So,
Negative secant 5 over 6.
negative secant pi over 6. 12 problems we had for homework. Questions on these?
Only got one wrong there.
All right, not bad at all. Okay, and then if we did, even ones we didn't get to, we feel like we understand it now. All right, let's. Yes, let me give you some more practice with radians, because we didn't do a lot of practice last lesson with radians, and I feel like even though we did fairly well with it here, I think a little bit more practice just to lock those down. I feel like degrees we're really solid on. Just want to make sure radians aren't going to give us any trouble, and we're able to mentally picture. I want us to see if we can work on mentally picturing these angles. All right, so let's go with the cosecant of 9 pi over 7, the sine of negative 3 pi over 5, the tangent of 4 pi over 3, cotangent of negative 11 pi over 6, the secant of 7 pi over 4, and the cosine of 8 pi over 3. Oh, Chris, this is yours.
I thought I already got it, dude.
Yeah, you did, and you left it under your desk. You might want to put that somewhere where you're not going to leave it and forget it, so that way you can at least return the book so your fine doesn't keep going up, right?
No, he doesn't care. He likes paying school money.
I like helping people out.
Okay.
There you go.
Are you at least enjoying the book?
Yeah, it's good. I already did a book report on it.
Yeah, after you didn't read it.
It's insightful to see the struggles that some people, go through. Even you think superstar athlete, right? I mean, one of the greatest quarterbacks ever to play the game, and he did not have an easy life. It was not all
Who?
Terry Bradshaw.
He got bullied a lot.
Yeah.
Being old stupid and stuff like that.
I don't know.
Make sure you realize how mean people are.
And I mean, that was back in the 70s. We think people get meaner and meaner. Well, they do on social media, right? But people have been sinners for years,
Yeah, I don't understand cyberbullying, to be honest.
I don't know what's up with all the third quadrant angles, but that's 3 in a row. I don't know that was intentional. By the way, do you see the speed at which we ought to be able to process?
Yeah, that's going to take a long time.
It's going to, I'm not expecting you to be this quick at first,
You
right?
ever had a student be that quick at first?
Not right off the bat, no. But again, quickly identifying where is it in relation to 7/7 or 14/7. Where is it in relation to 5/5 and 10/5. By the way, this one's close, isn't it? Right, if this is 10/5 of a pi, this is 5/5. 7 is barely closer to 2 or 5 than it is to 10. So just barely still in the third quadrant. It almost hit that fourth quadrant mark. 8/5 would have been in the third quadrant, or in the fourth quadrant, but.
Can you minus 2 pi away?
No, because well, yes, if it's too big. For instance, if this had been like 17 pi over 4, then yeah, you'd subtract 8 pi over 4
like
away.
the second one? I like the last one, I mean.
Yeah, like the last one. Because it's too big, right? It's like having an 800-degree angle or something. So you subtract 360. Well, here it's in radians though, so we would subtract away, right, the 2 pi. Questions on radians. Are we starting to visualize the pi and 2 pi in fraction form a little bit quicker?
I didn't even write them.
Good, awesome. And you got them all right? Outstanding. All right. Quentin, all correct. Checking over his last answers there.
This one.
Miss which one?
The cotangent.
This one here?
Or no, not the cotangent, the secant.
The secant one. The next to last one. All right. Not too big, right? Because too big, right? If we were writing it out, 8 pi over 4 would be your 2 pi, and then 4/4 here. Obviously, 7/4 is very nearly 8/4, right? So that puts it in the fourth quadrant. 7 pi over 4 would be pi over 4 way. But remember, ASTC is cosine's quadrant in the fourth, but secant goes along with cosine, hence the positive secant pi over 4.
I think I did. I wrote quadrant 30.
Yes, 7 is, where is the 7? Is it closer to 4 or 8? Clearly closer to the 8.
So if you don't write positive, is it assumed positive?
It's assumed positive, yes. If you have it positive, you could leave it understood. That would not be wrong. However, I will say if you write it, you're not going to, when you're going back and checking your answers, you won't fear that, oh, did I forget ASTC, right? So by writing the positive, you know you took care of the ASTC mental step. Since we're not writing that step anymore. Let me give you a few more. Let me mix it up this time. Some angles, some degrees, and some radians this time. Kind of like what we had in the homework.
cosine of 10
Well, we added 360 to get 170.
Right.
That puts it in quadrant 2.
Right.
And in quadrant 2, you're measuring from the 180, you come up 10 degrees,
Okay.
right? So 10 degrees from 180 is your reference angle. Then in quadrant 2, cosine's negative. So negative cosine 10. By the way, the purple is in honor of the Ravens' victory last night over the Chiefs.
Oh, yeah.
Just for you.
That
That
was
was
like a fumble.
so lucky.
No, it was not. They fumbled the ball. It wasn't lucky. That was our defense. We ran the ball all over them last night. They could not stop a rush.
Was it all Lamar Jackson or was it the running backs primarily?
It was both.
I thought Lamar Jackson was out of the league.
Lamar could not really throw. He threw 3 interceptions.
Mm-hmm.
Yeah, I thought Lamar Jackson was out of the league, to be honest.
What do you mean?
Man, it's trash now. He won
No,
his
he's
MVP
not.
and did.
No, he's not
Man,
trash.
won his MVP, went to the Browns game, used the bathroom, and left.
Alright, anyway. There's your quarterback.
Who's your NFL team anyway, Chris?
Miami.
The quarterback with Tua
His
Tagovailoa.
quarterback just got hurt. Did he just get hurt? Yeah.
Again.
All right. Questions on this? We'll real quick the answers just in case it doesn't show up well on the video, but I want to use purple for Ethan. Quadrant 3, reference angle 65, so negative secant 65. Here, add 360, get 170, quadrant 2, reference angle 10, so negative cosine 10 degrees. Here, subtract 360, you get 172, that's in quadrant 2, reference angle 8 degrees, negative tangent of 8 degrees. Here, quadrant 3 is a little beyond that 6/6, reference angle 1/6 of a pi, negative sine, pi over 6. Here, 13 pi over 5 is too big. Subtract 2 pi or 10 pi over 5 to get 3 pi over 5. Now, that's just barely in quadrant 2, right? 0 pi's, 5 pi's over 5, right? 3 is a little closer to the 5, so we are in quadrant 2. Reference angle 2 pi over 5, negative in quadrant 2, cotangent 2 pi over 5. Here, negative angle, add 2 pi or 20 pi over 10 to get 13 pi over 10. That is beyond the 10/10ths of a pi into the third quadrant. Reference angle is 3 pi over 10. Quadrant 3 cosecant's negative, negative cosecant, 3 pi over 10. Anyone go 6 for 6? All of you, excellent. Questions on this?
I'm scared we're gonna have a quiz.
We are going to have a quiz. Clear desk, except for clean sheet of paper, pencil, and a calculator. Clean sheet of paper, pencil, and calculator. Everything else away. He is very, very astute, very intuitive.
I knew we were going to have one. Right.
First last name at the top of your paper along with today's date, which is 9/20/21. 9/20/21. Are you okay? Are you okay?
Are you joking?
Keep coughing, keep coughing. I learned that in first aid class.
Are you joking?
To need the Heimlich maneuver.
Quentin will gladly give it to you.
He's breathing.
Oh man.
All right. All right, first last name. Now that we're done dying. First and last name. Glad you're okay. First and last name, 9/20/21, today's date. Let's take a look at this quiz. Oh, no calculator. I'm sorry, no calculator. Put that calculator away.
What?
No calculator needed for this quiz here. That's what it says on top. Do not use a calculator on this quiz. Who am I to go against directions? Numbers 1 through 3. Numbers 1 through 3, just asking for the quadrant that satisfies those conditions. 4 and 5 asking for some reference angle formulas. 6 and 7, similar to what we did for a couple of days there end of last week, except you're not finding all 5 other trig ratios. You're just finding one of the trig ratios that I want. So thinking, okay, sine is this over this, so I'm missing this. How do I find this other? Okay, and then thinking about ASTC as well there on 6 and 7. And then for 8, 9, and 10, that's more similar to what we were just doing, reducing to the same function of a positive acute angle. All right, you may begin. Use that quiz copy as a cover sheet. Yes, sir.
Notice this reading space 6. I need to write this up because I can't see it.
That would be good. Since we're recording, please don't sing it. Also, since there's students are Yep. But we're going to do exact values, not decimals anyway, so we don't need a calculator.
Okay.
Yep.
Gotcha.
Yeah, so exact values on 6 and 7. So instead of saying, 3.74298, whatever, you do like square root of 11 or something weird like that, depending on what values work.
We draw on say number 8, we were to draw the graph itself, would we get extra credit if we place errors?
Not extra credit, no, but it would help you get the right answer.
Extra credit, I mean like
Partial credit,
Partial
potentially.
credit.
Yeah, of course. Any work you show is always going to give you partial credit. As long as the work is correct. I'll be finishing up in the next minute and a half or so. This time should be finished with your quiz, so go ahead and pass those quizzes in. Next section in your notes. Next section in your notes. Reducing to the cofunction of a positive acute angle. Reducing to the cofunction of a positive acute angle. Obviously this sounds a lot like what we just did, except we said reducing to the same function of a positive acute angle. So how is this going to be different? Well, step number one is reduce to the same function. Reduce to same function of rho. In other words, do what you just did. The first step is all the stuff we just did. What quadrant, what's the reference angle, ASTC, all that stuff. And then we're just going to add a couple more steps to it. So basically this is what we were just doing, but with a couple additional steps. Step number two, since we want to change to the cofunction, then change to cofunction. But you'll recall from the past that when you change to the cofunction, you also have to change the angle to its, not reciprocal angle, co-angle or complementary angle. So step number three, change to complementary angle. Quick refresher, that means 90 minus the rho that you would have found in step one, or pi over 2 minus the rho you would have found in step one. So we change to the cofunction, change to the co or complementary angle. But step number 4, put this in all caps, keep the same sign, S-I-G-N, sign. Keep the same sign. So in step 1, as you reduced to the same function, you found a particular sign based on ASTC. You keep that. So we're not basing things off of the cofunctions ASTC, but the same function ASTC. Let's do several of these together. First of all, the sine of 120 degrees. We start by doing exactly what we were just doing earlier in the hour. We say, what quadrant, class?
1, 3, 2.
2. Reference angle from the 180, 60. ASTC sine is positive. So initially we get positive sine 60, right? Just what we just did. Now we're going to change to the cofunction class. Ooh, not reciprocal, cofunction. Cosine. We're going to find the complementary angle of 60. Complementary angle, 90 minus 60. 30. But we're going to keep this positive. You say, well, quadrant 2, cosine's negative. It doesn't matter. Positive, because we're finding the complement of positive sine 60. We're not finding the complement of the sine of 120. And that changes to the cofunction. So again, for starters, same quadrant, reference angle, ASTC, all that stuff. Write the cofunction, complementary angle, and then keep whatever SIGN you had before. So for the cotangent of 410, well, earlier in the hour, we would have said, oh, that angle is too big. We need to subtract 360, and that would give us the cotangent of 50, and that's in quadrant
1.
Oh, so earlier in the hour, we would have said we're done. But now we're ready to change to the cofunction. So instead of cotangent class, tangent. Instead of 50 degrees class, 40 degrees. But since this is positive, this is going to be positive as well. We'll leave the positive understood in this case. There we go. Did we see what we're doing? We're kind of taking 2 steps at once. We already practiced changing to cofunctions earlier in the year. We've practiced reducing to the same function. Now we're doing the 2 steps back to back is all. That make sense? So this next one, the tangent of 9 pi over 5. Ooh, is that too big?
No.
No, because what's 2 pi? 10 pi over 5. It's really close though, which obviously means it's in quadrant 4. Reference angle,
Pi over 5.
right, it's pi over 5 away from the 10 pi over 5, and ASTC, negative. So initially, negative tangent pi over 5. Now we're ready to change to the cofunction. So instead of tangent class, cotangent. While we're at it, let's go ahead and keep the SIGN. Let's keep this negative. But what about the angle? I need the complementary angle, which means I need to subtract from pi over 2.
Which you have to have the same denominator.
So I'm going to have to do pi over 2 minus pi over 5. The common denominator in class is going to be 10. So multiply top and bottom by 5 to get 5 pi over 10. Top and bottom by 2 to get minus 2 pi over 10. What's the complementary angle? 3 pi over 10. And there's rewriting this function or reducing this to the cofunction of a positive acute angle. Does that make sense? Let's do a couple more. Thoughts?
Tangent positive.
Yeah, we need to add
2 pi.
2 pi, which would be
Negative 5 pi.
24 pi over 12. So that gives me secant of
17 pi.
17 pi over 12. Ooh, this is going to be fun. So pi would be 12 pi over 12. 2 pi would be 24. Is 17 closer to 12 or 24? 12. It's 5 away from 12. It's 7 away from 24. So it's closer here, so it puts it in quadrant 3. Not by much, but it is still in quadrant 3, correct? Now then, reference angle. How far from 12 twelfths of a pi is 17 twelfths? 5 twelfths. So 5 pi over 12. And ASTC?
Positive.
Negative. Quadrant 3, tangents, quadrants, negative. So negative secant 5 pi over 12. Now, let's reduce to the cofunction. What do we do with the SIGN? Keep it. Instead of secant, though, cosecant. And instead of 5 pi over 12, I've got to subtract that from pi over 2, half a pi. Well, pi over 2 minus 5 pi over 12, what's the LCD?
12.
12. Multiply top and bottom by
6.
6 to get 6 pi over 12. So the complement is
5.
pi over 12. And I've reduced this to the cofunction of the positive acute angle. Again, the main step is just get same function. Do what we already were doing. But then keep the SIGN, change to the cofunction, 90 minus or pi over 2 minus the reference angle that we already found. So for the next one, cosine 210. Angle looks good, finally. Quadrant? 3. Reference angle? 30 away from the 180. ASTC? Negative. ASTC, quadrant 3, the tangent quadrant. So what do we get initially?
Negative cosine of 30.
Negative cosine of 30. Others are allowed to answer as well. Now, I want to change to the cofunction. So what do I do with the SIGN? Keep it. Cosine turns into sine. And instead of 30 degrees, 90 minus gives 60 degrees. And there we go. Feel like we're getting in the groove on this, because you're going to have some practice with this in your homework. All right, cosecant 3 pi over 4. Last problem, and then we'll be done. Quadrant?
2.
2, good. 4/4 here, 3/4 not there yet. This is quadrant 2. Reference angle? Pi over 4. ASTC? Positive. So positive cosecant pi over 4. Now, let's change to the cofunction. What do we do with the sine? Keep it. Cosecant changes into secant, cofunction, remember. And then for the angle, pi over 2 minus. So pi over 2 minus pi over 4, what's the common denominator? 4, top and bottom by 2. So this becomes 2 pi over 4, so we get, and that actually makes sense. If you think of pi over 4 as 45 degrees, the complement of 45 is 45. This is what you're going to be doing in the homework this evening. Page 60, I need you to turn there in your books. Page 60, I need you to turn there in your textbooks. We're going to ignore the directions a little bit here, okay? So on numbers 13 through 16, read the directions with me as I read them aloud. It says, read silently while I read aloud. Rewrite each of the trigonometric functions of the angle as the same function. Cross out the word same and put co. And what we're going to do as well is, like before, I'm going to give you a specific function for each of these. So on number 13, I want you to write secant. Number 13, we're going to do the secant. You can write this directly in your book if you want. Number 14, tangent. Number 15, cosine. And number 16, sine. Now you'll notice on 17 through 20, it already says cofunction, right? And it already gives you a trig function. So numbers 13 through 20, or 17 through 20 was already good. I just needed to doctor up 13 through 16 for you. Your homework tonight is to do 13 through 20 on page 60 using the functions I've given you, and we're doing all of them as cofunctions. Also, lesson 32, Friday for you guys. That's a test over chapters 3 and 4. Friday will be your test over chapters 3 and 4. Have a wonderful rest of your day, and you are dismissed.